Hello everyone. In this lecture, we will discuss about CMOS fabrication. So what is CMOS? Complementary metal oxide semiconductor. So that means in this fabrication, we are going to integrate two different technologies together. That is why it is known as complementary. So what are those two technologies? One is N-type technology and another one is P-type technology. So we can fabricate CMOS inverter by using different processes. So in this lecture, we will discuss about using N-well process. So in this CMOS fabrication, the first and foremost step we have to do is we have to select a P-type silicon substrate. So firstly, we will select the pure P-type silicon substrate and then we are going to form N-well. So here the substrate and the well should be opposite to each other. That means since we have taken P-type substrate, we need to form a N-well. So on the next step is thermal oxidation. So here the substrate is heated up to very high temperatures, is around 10,000 degrees Celsius, and then silicon dioxide is deposited on the substrate. This silicon dioxide acts like a barrier and protects the substrate from the contamination. And then we are going to deposit photoresist all over the surface. So where we are going to expose it to the UV radiation. Before exposing it to the UV radiation, so we need to prepare a mask. So this mask protects the other regions from the UV radiation exposure. So we are going to expose a certain region in the substrate where we require a N-well. So only that portion is exposed to ultraviolet radiation and then the other regions are protected by the mask. This step is known as masking. Next, we will remove the photoresist where we need to create a N-well. So this is done with the help of a chemical which is known as trichloroethylene. So and then we will move on to the next step, which is nothing but removal of oxide. So the layer of silicon dioxide is removed with the help of a solution known as hydrofluoric acid, and then we will move on to the next step, which is known as removal of whole photoresist layer. So previously we have removed only certain region or certain portion of layer. So here in this step we are going to remove all the layer of photoresist. So here we will take the help of solvents like H2SO4. And then we are going to diffuse N-well inside the P substrate. So this is done by heating the substrate at the higher temperatures and then N-type impurities are introduced inside the substrate. So here you can see the formation of N-well. So inside the N-well we are going to create P-type device. And after that the leftover silicon dioxide is again removed with the help of a chemical known as hydrofluoric acid. So next we are concentrating on the deposition of gates. So here in this technology, since we are integrating two different technologies, we will be requiring two different gates. So with the help of chemical vapor deposition, so we are going to deposit the polysilicon all over the surface. So which will create two gates, for one for N-type device and another for P-type device. And then we are going to remove the extra polysilicon which is present all over the surface. So other than the gate regions where we require gate terminals. So and then we will carry out once more the oxidation process where we are going to deposit silicon dioxide all over the surface for better protection. Next, we'll focus on the formation of N-type device. For that purpose, we need to repeat few more steps. Those are masking and then N plus diffusion. So here, once more we will expose the substrate to the UV radiation where we require gaps for source and drain for N-type device. So here you could see the ion implantation process. After removal of excess oxide, we are going to heat the substrate and then we are going to introduce N-type impurities through the substrate. So we could see N plus drain, N plus source, and once more here you could see inside the N well there is a N plus impurity, so which acts like a substrate connection. And then we will remove the extra layer of oxide which is present all over the surface, because we need to focus now on integrating PMOS technology inside the CMOS fabrication. So now we are going to heat the substrate once more at higher temperatures, and then we will introduce P-type impurities through the substrate. So here our focus lies in the N well. Why? Because we need to form a P-type device inside the N well. So we are going to repeat few more steps such as masking, and then diffusion is carried out. That means P-type diffusion is carried out. So here we are going to fabricate P-type drain and P-type source, and then P-type substrate connection. So and then for better protection and avoiding contamination, we need to once more form a thick oxide all over the surface. Next, we will carry out the process of metallization. So where aluminum is deposited all over the wafer for giving connections to the external region. Next, we will remove the excess metal from the surface. Why? Because we require only the interconnections at the terminals, such as substrate connections, sources, drains, and gates. So the other extra metal which is present other than these regions is removed. And we will form the terminals at the gaps, so wherever we require interconnections. So and these terminals are nothing but substrate terminals as well as sources, drains, and gate.